In this video, we will be performing reflections when we are given their rule, and we will be identifying reflections that have already occurred. In previous videos, we learned how to draw a reflection when we are just given the line it reflects over, and we developed some rules and noticed some things about reflections, namely that they have the same angle measures, the same size, they are congruent, but they have different orientation. It may be helpful to remember the transformation rules that we developed, which are the ones highlighted in red. So when we reflect over the x-axis, we kept the coordinates the same, just made the y negative, and then the opposite for the y-axis, we just made the x negative. And then when we reflected over y equals x, we just swapped the coordinates of x and y. And when we reflected over y equals negative x, we swapped x and y and we made them negative. So now we're going to perform a couple reflections when given their rule. So first off, we have this one. We take x and y and we swap them. So there are a couple ways to do this. I'm going to show the first way, and then on the next example, I'll show the second way. The first way is to just find out what the coordinates are and swap them. So y is 0, 0, L is 4, 3, and z is 4, 0. Okay, so for this one, we're going to swap all the coordinates to create the image. So 0, 0 is 0, 0, swapped. For this one, we're going to put 0 first and then 4 second. And then for this one, 3 goes first and 4 goes second. Now I'm going to plot all the image points. So y stays the same. Then z is now 0, 4, so it's going to be up here. And L is 3, 4, so it's going to be right there. Now you should be able to tell that this is a reflection over this diagonal line right here, which is the line y equals x. And if you look up above when we did reflecting over y equals x, what we did was this rule, xy to yx. So the other way is, if it's easier for you to draw the line of reflection and then reflect over that line, to just recognize what it's doing and then to do it. So on this one, we're going to perform the reflection, xy, go to x negative y. So I noticed that the y is changing and the x is staying the same. So I know from my rules that that means it's flipping over the x-axis. And you could even test this with just one coordinate. You could be like, okay, I got y. This is 0, 1. I'm going to, if I were to flip over the x-axis, then it would now be 0, negative 1, which follows my rule. So I'm just going to flip them all over because it's going to be a little bit easier for me to just count from the x-axis and go the opposite. And then W is 4 up. So that is the other way you can do it. Oh, I did that wrong. I connected to y instead of y prime. Hang on one sec. There we go. That looks so much better. All right. You may sometimes be asked to describe what the reflection was, and all you have to do is say reflection over what line it reflected over. So this one was y equals x. And this one was the x-axis. Okay, now on these two, we don't even have to draw. We just have to figure out what the line of reflection was. So you're looking for the line that both shapes are the same distance from. This one's pretty easy. It looks like it's that line right there. So it reflected over the y-axis. Now for our function rule, if you know the rule, you could just write it. The other way that you can figure it out is you can go and look at a couple points and see what happened. So this one was 2, 1. This one's negative 2, 1. So it looks like the xy stays the same, but just x is negative. And if I were to look at my rule, when I flipped over the y-axis, it was xy arrow negative x, comma y. Let's just make sure that that holds for another point for m. This was -1, -2, and this one was 1, -2. So yeah, just the x coordinate swapped. By swapped, I mean it changed. It made it the opposite. Okay, for this one, ooh, this one's a little wonky. It looks like it was maybe over a diagonal line, so let's check. And I think we're right. Let's go ahead and check it. I'm just gonna check the pointy parts of the shapes. Yeah, that looks like a mirror image. That looks like you could fold it evenly over that line. Okay, let's check just the butt end of the triangle. Yeah, that looks like a butterfly. That is reflected evenly. So this is over, ooh, what is that line? That line is called y equals, it has our plus b is 0, and the slope is up 1 over 1. So this is the line y equals x. And then our function rule, we could just look up and know, or we could find the points. I happen to know that when we flop it over y equals x, that you're just going to swap the coordinates. And I know that from before. However, you can do what we did before and see what happens. Just find what happens between b and b prime. And you'll notice that b prime is 4, 2, and b is 2, 4. So yeah, we swapped. And then just check and make sure it works for all the points, and then you'll know that you did it right. All right, good luck.